In this video, we'll be classifying a triangle by angles using its side lengths. Okay, so remember the angles could be acute, obtuse, or right. All right, so let's start with the middle column because that's the one we're most familiar with because this is the converse of the Pythagorean theorem. So remember, the Pythagorean theorem says that if you have a right triangle, then a squared plus b squared equals c squared. The sum of the legs squared, the sum of the square of the legs equals the hypotenuse squared. All right, so the opposite of that, if I flipped it around, said if a squared plus b squared equals c squared, then the triangle is a right triangle. Okay, let's go to the left. So if we have a squared plus b squared, and its relationship with c squared is that the small sides dominate. If the small sides dominate, then the triangle is acute. Triangle is acute because the small sides, the sum of the squares of the legs, dominates. Okay, that's greater than c squared. And then on the far right, if a squared plus b squared is less than c squared, if the big side dominates, then the triangle is obtuse. Because this angle opposite the big side, since the big side dominates, that angle opposite the large side is going to be obtuse. Therefore, the whole triangle is obtuse. All right, so this is how you classify using the side lengths. You use that a squared plus b squared and then c squared relationship. All right, but the first step, which is why we started in the first video with the triangle inequality theorem, the first step, do you have a triangle? Do you even have a triangle? So that's the first thing you have to do, guys. Okay, you have to see, do you even have a triangle? And then if you have a triangle, then you can do a squared plus b squared and see what its relationship is to c squared. All right, so remember, to figure out if you have a triangle, you take the small side plus the medium side, and that has to be bigger than the large side. Okay? And then if that's true, then you can do a squared plus b squared and see what its relationship is with c squared. All right, it's a two-step process. So let's go over some examples. Classify triangles with the given side lengths. Classify whether it's acute, obtuse, or right. So you see we got 15, 3 square roots of 61, and 17.2. Well, the first step we need to do is it a triangle? Is it a triangle? All right, in order to do that, we need to see what is the small side, what's the medium side, and what's the large side. But we got that 3 square roots of 61. So what I'm going to do is use my calculator, 3 square roots of 61, and I'm going to see that that's about 23.4 blah, 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 blah. So that is its decimal approximation. All right, so now that I've got that, I can identify these as the small side, the medium side, and the large side. Okay, so is it a triangle? Is 15 plus 17.2, is that greater than 3 square roots of 61? Well, 15 plus 17.2 is going to give me 32.2. Is that greater than 23.4, blah, 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 blah? Yes, it is. So is it a triangle? Yes. Now that it's a triangle, we can see what is its relationship between a squared plus b squared and c squared. What can I fill into this opening here? A less than, greater than, or equal to sign. All right, so a squared, that's going to be the small side squared. So 15 squared plus the medium side, which is 17.2 squared. And we want to see what is its relationship with 3 square roots of 61 squared. Notice I got parentheses around these. You got to be careful with those parentheses. All right, 15 squared plus 17.2 squared is going to give me 520.84. 3 square roots of 61. It's in parentheses and I square it. That's going to give me 549. Okay, because that's going to be, remember this is 3 square roots of 61 times 3 square roots of 61. So it's 9 times 61, which is 549. All right, so now that we've simplified those, what's the relationship here? Well, c squared dominates. All right, 520.84 is less than 549. So the big side dominates, therefore this is an obtuse triangle. Based off its side lengths, since all the side lengths are different, we could also say that this is scalene. All right, but I know it just wanted the angle measure, or the angle classification, which would be an obtuse triangle. Okay, so that's the two-step process. Is it a triangle? If it is, then you can move on to see what type of triangle it is based off its angles. All right.